Has had a bunch of different missions. You should know about them since you're taking an astronomy class, and you're living in the United States. You should probably know about what has gone up there. Yeah.
This is kind of random, but referring to satellites, how does like DirecTV and stuff get their satellites up there? Do they like?
They hire NASA to launch them up there on rockets.
Oh.
However, it's now being taken over by private administration. There's companies like SpaceX. Are you doing SpaceX?
I'm doing SpaceX.
SpaceX, they can take stuff up there in their capsules now, because you can make money off that.
Right.
If you can do it cheaply enough. And so it's starting to be taken over by private. But it used to be just NASA. You would have to hire them, hire one of their rockets, and they launch it up there for like $100 million or something, just a lot. Yeah. And they did that for years and years. And there's lots of, if you get it going at the right speed, there's very little friction in space, so it'll orbit and orbit and orbit stay up there for not forever, because there is some molecules up there in space from the atmosphere that get up there really high, and the Earth loses sometimes some molecules, and it'll slowly slow the spacecraft down, and then it'll fall back to Earth eventually. But it depends how far away it is, but it could take hundreds of years to fall back to Earth. Good question.
Gosh, Mommy.
Okay, let's talk about the Pioneer mission. So the first missions, they went very, very far away from Earth. They were launched to study Jupiter and Saturn, I think, were the Pioneer spacecraft. And they were testing a lot of stuff, if they could launch a satellite very far from Earth. They launched it up there on a rocket, they let it go. It flew around some of the planets, took some pictures, did some maneuvers, kind of learning how to run these satellites in far outer space. So they were called the Pioneer spacecraft. They're sailing off into space right now. They all have a plaque on them that looks like this. This is a plaque where they hired some scientists. One of them was a guy named Carl Sagan. Do you know who he is? He's my favorite scientist. I got all his books over there. He wrote the movie Contact. He actually wrote the book Contact, and they made it into a movie. So yeah, Contact, Carl Sagan. Anyway, they hired this guy. He's a scientist, and he helped make this plaque. And what this plaque is, it could be picked up by some extraterrestrials, if there was a smart enough alien out there somewhere, they could find this plaque and decipher where it came from and what we look like. And that right there, that thing, the square, and that curved thing, and that thing, that's the spaceship. That's the Voyager spaceship. So it shows how big humans are compared to the spaceship. And it shows where we came from right here. There's the sun, and there's the first planet, second planet, third planet. We're the third rock from the sun. And that's the voyage it took. And there's a little spacecraft there. And this big thing here is directions to our planet from some nearby pulsars, which are spinning stars. And this right here is binary code, where you can figure out the speed, the spin rate of these pulsars, figure out where the pulsars are, and then figure out where the Earth is based on the spin rate of these pulsars, which don't slow down for millions of years. And that right there is the hydrogen molecule. And that is the showing the opposite spins. Have y'all studied that electrons have opposite spins in chemistry? Did y'all study that in chemistry? Some electrons spin this way and some have an opposite spin. This shows the opposite spins, and it makes it so there's a down spin or an up spin. And this is used as the binary code for this. For these, that's code using the spin as the plus and minus as a binary code. Do you know what binary is? Numbers. Numbers 0 and 1 is computer code. You can use zeros and ones to write out anything in computer code. You know about that? It takes 8 zeros and ones to make a number or a letter. Computers. 8 bits make a byte.
So is the Pioneer spacecraft, the first one, is it still like sending us stuff?
No. It's off. It ran out of battery power. It's just floating out there in space.
So we just hope somebody, well, maybe
somebody might pick this up
in
millions of years. It should be there for billions of years, just floating out there in space. Isn't that cool? Now there's another one called Voyager, which we are still getting signals from. We launched it in the 70s. And it went around the planets. Let me show you on this next picture. It shows the Voyager. So we launched it in 1977. Santana, you with me up here? We launched it in 1977. The spacecraft took off. It went around Jupiter in 1979. They went around Saturn in 1980. Voyager 2 went past Uranus in 1986 and past Neptune in 1989. And Voyager 1 went Jupiter and then Saturn and then off into space. And so these two spacecraft took all the pictures, almost all the pictures that we have from Jupiter and from Uranus and Neptune. They're the only craft that had visited Uranus and Neptune was Voyager 2. Took a lot of pictures, and Voyager 1 visited Jupiter and Saturn and is now off into space. They used a technique called gravity assist, which is a very cool technique. Let me show you how it works. Here's a planet flying along. Let me get a little pencil as the spacecraft. Here's a planet going along in its orbit. What if a spacecraft was coming to it like this? Well, it can use the gravity of the planet. The gravity of the planet will make the spacecraft fall towards the planet. And the spacecraft can speed up a lot, especially if the planet's big like Jupiter. And the spacecraft will fall toward the planet, and then loop around it. If you go too close to the planet, you'll hit it. And if you're too far from the planet, you can't use much of its gravity. But if you go by the planet just right, you can loop around it and get what's called a gravity assist or a gravity slingshot. And you slingshot around the planet and you have sped up your craft a lot. You can get going faster from a gravity slingshot with a big planet like Jupiter than you can from rocket thrust. To go around the planet like that, just a few days. You can go around a smaller planet faster than a bigger planet. Jupiter, a few days. The Earth, a few hours. So you can see where it used the gravity assist. It also turns your spacecraft. So they had all the planets lined up just right where this thing could gravity assist Jupiter, then gravity assist Saturn, then gravity assist Uranus, and then see Neptune. And so it picked up speed all along the way. It's traveling really fast now. And it's heading out into space. And it sends us a signal every year at Cup 2. It should keep doing that for another decade or two. And just tells us where it is and how fast it's going and gives a few readings about the temperature of space and that sort of thing. It's really cool. It's the farthest spacecraft from Earth. Voyager 2 and Voyager 1. I'm not sure which is farther. I would think it'd be Voyager 2 because it did more slingshots than Voyager 1. But I'm not exactly sure. Aren't those cool missions?
Yeah.
Voyager, that's the farthest thing we have from Earth. By the way, those spacecraft also have the funny-looking plaque on them, this thing. But with Voyager spacecrafts, they also, I think, have a record. A big, like a CD, like a DVD. But back then they were called laser discs. And it has a bunch of pictures of Earth on it. And sounds of Earth. It has like whale sounds and stuff like that. Keep people saying, hey, we're people. And if it was an alien civilization that got that record,
Right.
maybe they could figure out how to play it and listen to those songs.
Oh, hi there.
Has there ever have we ever found things in space that are like not like pieces of equipment?
From some other civilization? No. As far as we know, we're the only ones around. But we're listening. We're hoping there's others.
We're not.
The Space Shuttle program. They started this when I was y'all's age. And they retired it recently. 2011 was the last Space Shuttle flight. They were just too expensive. But these things, they were made, they looked like planes. Has a real big cargo hold. You could fit a lot of cargo in there. That whole top there will open up. It's like a convertible. And that thing will open up and it's got a big robot arm in there that can drag something out and leave it in space. And they launch it using these two big rocket boosters. All of these three things are filled with gas. So it shoots off the launch pad, and then these two side things fall off, and then it goes for a while on this one, and then that falls off, and this thing's left out in space. And this thing can land like an airplane can land on a runway. So it doesn't have to splash down in the water like the old Apollo program.
How does it slow down?
How does it slow down?
When it's coming back.
With the atmosphere. When it comes back to the atmosphere, it hits the atmosphere, and the air slows it down. The
That's
bottom
enough?
panels heat up really hot. One of them blew up because one of the tiles on the bottom fell off. And the heat from re-entering the atmosphere ate through the craft and punched a hole in the craft, and then the whole thing blew up. Pressure. Yeah, killed everybody. There were 5 people in it.
Was that the one in the reading you was talking about? That it died quickly, they all died really quickly because of a gas?
There were 2 of them. The one with the teacher blew up just after launch. There were 2 of them that blew up. Out of something like 98 launches, there were 2 of them that blew up.
Wasn't terrible.
Or maybe 100. Maybe
98%.
Yeah, they had a pretty good percentage, but not a perfect, unfortunately. The one that blew up just off the launch pad was in 1986. That was my senior year.
That's sad because people are going down so long.
Yeah, there were a lot of people there watching. And that year, I had watched, or no, the year before, I had watched the launch down there. Yeah, it was the one I watched was successful. We went down there. I went down there 3 times. I watched 2 successful launches, and one of them was canceled. It was canceled with 20 seconds left in the countdown.
Why?
Because something was wrong with it. Something wasn't working right.
Good they found it.
And there's a time in the countdown where they can no longer abort the mission, and it's like 19 seconds. And they stopped it at like 20 seconds.
It says here that Atlantis is named after the RV Atlantis from the school.
Really? Ha! That is sweet. I didn't know that. That's in your reading?
No.
You were just Googling it? There's one of them landing. Space shuttles are real cool. They have one of them in the Smithsonian now, I think. The shuttles are all on display in different places.
The one in Washington, D.C., they have one like tour.
You can go on it? See? That's cool. Did you go on it? Was it big?
It's like, they only let you go into part of it,
Oh.
and it's like really narrow.
What, did you go in the front?
No, I went in the
No.
next section.
In the middle? Look at all those big rocket thrusters. Pretty cool spacecraft. Galileo. So they launched Galileo it was a mission to Jupiter. It was a real cool mission because it flew around Jupiter and it launched a probe into Jupiter. It had a little remote control probe attached to it that it let go and shot into Jupiter, and the thing fell into Jupiter and had a parachute on it and floated down into Jupiter's gases. It went way down deep into Jupiter's atmosphere, and it finally got so hot it burned up. But we know a lot about what Jupiter's made of from that probe that went down there. The probe had all kinds of sensors on it to take temperature and pressure and composition, and we got some cool readings. And isn't that a neat ship? One thing screwed up on it. One of its antennas, when the antenna was opening up to send back messages, it stuck. And it was only like part of the way open, so they can only send messages back to Earth real slowly instead of quickly. So if they take a picture, instead of sending it back in just a few seconds, it might take a day or two to get the picture back. And so they can't send near as much data as they could have. So in that respect, the mission wasn't pulled out as perfect as they wanted it to do. You want to watch video footage?
It's been a little over a decade since NASA's Galileo spacecraft plunged into Jupiter's atmosphere and inside, but not before it changed the way we look at the solar system. I'm Amy Shear Title, and this is a Winter Space Day. Launched in 1989, Galileo was the mission that taught us that asteroids can have moons of their own. It was the spacecraft that found strong evidence of a subsurface saltwater ocean on Europa, and evidence that Callisto was similarly a wet moon. It found evidence
So these are moons of Jupiter that it looked at while it's going around Jupiter.
that tidal friction is responsible for gaining these molten core, a feature which gives the moon its own magnetic field. Galileo also gathered data that let scientists determine that the volcanoes on Io, which are caused by the expansion and contraction of that moon's surface, are hotter than any we have on Earth. Galileo also released a probe into Jupiter's atmosphere. The data this probe gathered as it fell on Jupiter's temperature and chemical composition helped scientists explain the raging storms that span the massive planet. For more on the Galileo mission and everything it taught us, check out the links below.
That was alright.
So are the storms just like storms of?
Yeah, they're like hurricanes.
That's
Big
not
hurricanes.
going on for a long time or
They
something.
go on forever on Jupiter because there's no land for them to hit and burn out like there is on Earth. So just like that picture over there, that's it. Jupiter has a big storm like that. That's its red spot. It has a bunch of smaller storms too. But we know the red spot storm has been going on for at least 300 years. There's the ISS, the International Space Station. So this was launched with the cooperation of a whole bunch of different countries, and they put it up one piece at a time. One space shuttle took up that piece, and another space shuttle took up that piece, and the Russians launched a bunch of stuff up there, and the spaceships can dock with it, and the astronauts can get on, and other astronauts can get off, and then the space shuttle flies away, or the spaceship flies away. Now the only things that go up to it are Russian rockets. We're trying to get some of these companies like SpaceX to make a ship that can go there, so we don't have to hitch a ride with the Russians. The Russians charge us a lot of money to do that. And since we got rid of the space shuttle, we don't have a machine that can go up there, even if we wanted to. If the Russians suddenly said, no, you can't go up there, we wouldn't have a way to get there. So hopefully these companies like SpaceX are going to have stuff that can go there pretty soon. But the ISS is going to be there for at least 10 or 20 more years, and there's scientists on this doing experiments, living, doing experiments. How cool a job would that be?
Yeah.
Video footage? I hate how it goes on the other one.
Hello, we're in the Soyuz. Jeff Williams behind the camera. We're out to the service module on the very back end of the station. We're going to transit all the way through to the shuttle, show you everything from one end to the other. Here we go.
Soyuz is the spacecraft that brings them there. The Russian.
Now we're into the service module. Very apt into the Russian segment. See a lot of the gear, the computers, cameras on the walls. We'll continue forward now. Our next stop will be the first juncture in the Russian segment, where we'll look down first into the docking compartment, and you see a progress cargo transfer there at the bottom. If you look up now, you'll see the brand new Russian segment, the MRM-2, the science module. Got a little bit of gear packed in it for the transit uphill, and they're starting to put it into work now. We're going to turn around, just take the lead, and we're in the FGB. A lot of cargo stored in the FGB. A lot of stuff. There's food, storage, some scientific material, stuff behind the walls, of course, stuff on the floor here. Little mirror here, place where you can clean up, take a bath. And now we're in the next juncture where we look down into the other Soyuz that is attached. It's a very juncture between the FGB and Node 1. Just backing up now into Node 1. There's some more storage area in this PMA-1, this beta adapter. And now we open up into Node 1. You can see Roman here. He's working on A-Red. And we'll turn around the other way. You can see Randy, Bobby, and Mike working doing some EMU treatment. Continuing into the lab. Say hi, Frank. Hello, Mr. Commander. That's it, Commander. Frank the Wind. Robotics workstations. See, this is basically a bicycle. Station's high. Okay. Good job, well, there's Bob first. In the flesh. Take care of Node 2. Coming up Node 2, of course, a connection for various parts of the station. Move up this way into Columbus. You can see the station spacewalking suits, the EMUs are stashed there on the ceiling, some more storage on the floor. Japanese experimental module, the gym, with another sleep station on the floor, other things stored here and there. A working laboratory. Coming up, we're into the shuttle now, through the primary thing you get after. Making the 90-degree turn. Now we're on the deck deck. There's our commander. Coming home off. Torch. And now we're continuing up to the flight deck. See the flight deck? Commander seat, pilot seat. We got a couple of seats removed here in the back that we'll have for entry. And then we'll look out the overhead window at station.
That's the space shuttle when the space shuttles were running.
We certainly hope you've enjoyed your tour from Soyuz to Shuttle. Thanks for all the great work everybody's doing on the ground supporting us. Thank you.
So do they have to bring oxygen up there too then?
Yeah, the oxygen, definitely it has to be brought. I'm not exact. I think they have scrubbers that can clean the air as they breathe, so it can kind of be reused.
Right.
Yeah, they like.
Yeah, I was about to.
They tie
I was about to
themselves
say.
to a wall or to the floor. Did you notice there was no floors? I mean, everything is wall because you can turn any way you want. So they have stuff all over the place. And if they want to sleep, they have straps. They strap themselves down so they're not just floating around. Isn't that great?
It's pretty compact.
Yeah, it's pretty tight. There's a lot of equipment on there. It's not like the spaceships you see on Star Wars or something like that, where there's just a lot of empty room and everything's on there for a reason.
Can they go outside of the space?
Yeah, they had some suits there. Did you see the space suits?
Mm-hmm.
For what's called a spacewalk. So they can go outside, they strap themselves, they have a line that keeps them floating away in space. And they can work outside if there's some damage or something they want to do. Yes.
When they look at the Earth, like when we see the moon and it's like half a moon or what?
Yeah.
Do they see the Earth the same way?
That's exactly how they see it, that picture. See, they're a lot closer to the Earth than you'd think. Like, if my fist is the Earth, they're just right above it. They're real close to it. So they can't see the whole thing. They can just see this blue kind of curved surface. Just like you see there, that's what it looks like.
Would you say that's dangerous for them to be up there? Like, is there a lot that can go wrong?
Yeah. I mean, it's probably pretty dangerous, but they do have an escape ship that if something goes wrong, they can jump in the escape ship and it can be released and it'll fall back down to Earth. And it'll be pushed down and then eventually it'll hit the atmosphere and it'll slow it down. It'll land somewhere. It's got parachutes. It'll land somewhere on Earth, probably in the ocean, and float around until somebody comes and gets them. Why probably in the ocean? Because there's more ocean than there is land. But, so they have emergency procedures where they can evacuate if they have to.
When people land in the ocean, do they send like a boat or a helicopter to come pick them up?
Either. The old capsules, they did both. Sometimes boats, sometimes helicopters. Yeah.
If you were to be outside in space and you didn't have any equipment on your hand, would your hand like freeze off?
Yeah. The pressure is the main part. So there's no pressure in space. So all the gases and stuff in your hand would expand if it was just touched outer space where there's no pressure. So that would be a problem. Yeah. Messenger is a spacecraft, kind of running out of time here. This one visited Mercury, went around Mercury, took a bunch of pictures. Messenger stands for Mercury Surface, Space, Environment, Geochemistry, and Ranging. Messenger. So you'll always see Messenger in capital letters because those stand for something. It's like scuba. You always see scuba in capital letters because it stands for something. So that was Mercury went around Mercury. A Messenger went around Mercury and took a lot of good pictures and readings and stuff. That was a NASA mission. I think there were a couple Messengers spacecraft. Cassini-Huygens flew around Saturn and took a bunch of pictures of Saturn. It launched a probe that didn't go into Saturn. The probe landed on Titan, which is the biggest moon of Saturn. And Titan's a really cool moon because it's got an atmosphere. Kind of like Earth has an atmosphere. It's the only moon with a thick atmosphere. And so they got good pictures of Titan, and there's actually liquid, not water, but liquid ethane and methane on Titan. It's like liquid natural gas. They got oceans of natural gas on Titan. And so they got lots of good pictures and stuff with the probe Cassini-Huygens sent. That spacecraft's still going around Saturn as we speak. And so is the Galileo spacecraft still going around Jupiter. And then the final one here is New Horizons. New Horizons was a spacecraft that was launched that did a couple gravity assists, did a gravity assist on Jupiter, and went out to Pluto. This is the one that took pictures of Pluto. We just got the pictures back this past year. And got a bunch of pictures. Now we know what Pluto looks like. When I was a kid growing up, no one knew what Pluto looked like. It was too far away. It's a little rock too far away. It's about the size of our moon. Maybe actually a little smaller than our moon. And it's we got pictures of it now. It's a big ball of ice, basically. Rock and ice. It's like a big comet floating out in space. So we're gonna we're going to talk about Pluto in a later chapter. So those are all the missions you have to know. So go back through that, study it, read the section. Could have a quiz tomorrow. And tomorrow we're going to review for the test. The test will be on Friday. Same as last time, multiple choice on the computer, and then an essay. Give me an essay topic.
Why is Mr. Willis a good teacher?
That's probably a little narrow, but maybe.
What would you have written on the slide?
Apollos.
Talk about all